All right, so welcome back. So now let's get into some of the definitions, and they're not really going to be formal definitions as much like the other two sections, but I think that I wanted to make sure you go through these notes because you're probably going to want to refer to these for a couple of days just until you really get a good solid foundation of what we're trying to achieve in this section, because I believe that this is kind of one of those first kind of shifts that's going to help us bridge our gap into the remaining sections of this chapter. So we have the kind of basic understanding. All right, we have quadrants, we have coordinate points, right? We know where they're positive in our quadrants. And again, just a reminder that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? Okay. Now, if you remember, I created my triangle R, all right? Or I created my triangle with X and Y. These are going to be the coordinate points. If we have a coordinate point X, Y. So here's X, Y, and then I'm going to call the hypotenuse R. So if we go back to our trigonometric relationships, we can represent sine as the opposite over hypotenuse, right? Which is y over r. So it's a little bit easier than actually just writing out opposite over adjacent. We can say it's the y coordinate over the hypotenuse, or r. And cosine will be x over r, tangent will be y over x. And then you can go through your reciprocal relationships. Now, again, these are all going to be based off of this angle here, which is our theta. Right? And again, if we looked at those triangles in the different, or we looked at those angles thetas in the different quadrants, those all represented our reference angles of an angle in standard form. The other thing I want to mention to you in this is that r is always positive, right? R represents the hypotenuse, so it's always going to be positive. However, x or y could be positive or negative. I don't know. It depends on which quadrant your triangle is in. So that's one of the things that we're going to kind of further investigate throughout this chapter. But we can really kind of summarize everything. If we know that the x and the y coordinates are positive in the first quadrant, well then sine, cosine, and tangent are going to be positive. Because again, look at the relationships. Sine, cosine, and tangent, if you're in the first quadrant, then y and x are always positive. Well, if r is always positive and x and y is always positive, then sine, cosine, and tangent will be always positive in that first quadrant. However, when we go to the second quadrant, notice how cosine and tangent are now negative. Now, why is that the case? Well, if you look in the second quadrant here, right? Let's kind of maybe do this. If you look in the second quadrant, we have a positive y and a negative x, and here's your r. So again, cosine is negative x over r, or it would be adjacent over a hypotenuse. Like here is your theta. Here's your right angle. So cosine's negative x over r. So that's going to be negative because r is always positive. And tangent would be positive y over negative x, and that would be negative. And again, you could do that for all the different quadrants. You can see over here, the y sine is negative because y is negative, so therefore tangent is negative. And then here, this one's important, tangent's positive. Why is tangent positive? Well, because x and y are both negative, right? If you look at the triangle down here, if x and y are both negative in the third quadrant, right? If they're both negative in the third quadrant, then the relationship of y over x is going to be positive, or x over y will be positive. And that's basically the connection that we now want to make with our trigonometric functions, our triangles in the quadrant system, and our coordinate points. And now we're going to go ahead and get into actually working through some different problems given this information in our process video. I'll see you guys over there.